All right, day 20. Oops. Let's get into it because I only got like 30 minutes to an hour to code today. So let's get to it. I know a little bit about maps because when I was doing my Advent of Code stuff, it was kind of crazy. All right, let's read the maps are similar to JavaScript objects. Yeah. So you do the make and two data types. Okay, complete the get user function. It takes a slice of names and a slice of phone numbers, turns a map of name and to user. Wait, oh god. Names of slice of names and slice of phone numbers to map a name and a user struct and an error. Okay, so I could do like name to map. Names yeah. Name to map or name to user. Okay, so we have the name. phone I think that should work. Okay, they're not equals, so I can't trust I. Well, can I just do this? If length of awesome, sick. Oh wow, AOT characters. Annie, Reiner, Sasha. Cool. Pretty straightforward here, I think. Insert an element, get an element, delete an element, check if a key exists. If key is in M, then OK is true and LM is the expect value as expected. If key is in the map, then OK is false and LM is the zero value for the map's element type. Oops. Delete if necessary. It's important to keep up with privacy regulations and to respect our user data. We need a function that will delete user records. check for the schedule for deletion bool to determine if they are scheduled for deletion or not. What is there? Okay. Someone here is an AOT fan. Super cool. It's important to keep up with the privacy regulations. Yeah. Check for the scheduled. Okay, if they are scheduled for deletion or not. If the user does not exist in the map, return. Let's do that first. I think we could do this. Okay. Return errors.new not found. Okay, if it's not okay, right? Then for every users so if they do exist, okay, if okay, we don't need to check for that. If not user dot scheduled for deletion, return false. No. That means if they exist and if they are true, if they are scheduled for doing, then we just delete them. So how do I delete? So delete users return true. No. Perfect. If I move on to the next one. Key types. Any types can be used as the value in a map, but keys are more restrictive. Read the following section in the Go blog. Oh. As mentioned earlier, maps keys can be any type that is comparable. The language spec defines this precisely, but in short, comparable types are Boolean, numeric, string, pointer channel interface types, and structs or arrays that contain only those types. Notably, absent from lists are slices, maps, and functions. These types cannot be compared using equals and may not be used as map keys. It's obvious that strings, ints, and other basic types should be available as map keys, but perhaps unexpected are struct keys. Struct can be used to key data by multiple dimensions. For example, this map of maps could be used to tally web page hits by country. This is a map of string to map of string to n. Each key of the outer map is the map path to a web page with its own inner map. Each inner map key is a 2-letter country code. This expression retrieves the number of times an Australian has loaded the documentation page. Fortunately, this approach becomes unwieldy when adding data, as for any given outer key must check if the inner map exists and create it if needed. What type qualify? Type that is comparable. Yep. You can check if a key is already present in a map by using the second return value from the index operation. If you can combine an if statement with an assignment operation to use the variables inside the if block. Oops. Main test.go. Get counts. All right. Remember that you can check if a key already exists. Yeah. Each time a user is sent a message, the username is logged in a slice. We want more efficient way to count how many messages were each user received. Get counts. It takes a slice of strings and a map. It should update the so if Benji is in the map and appears in the slice 3 times, the key Benji in the map should have a value of 3. Okay. So let's for every user, actually it's the users, update the valid map with the number of times each user has received the message. Each string in these slides is a username, but they may not be. Let's continue, I guess. Or what if I should say if okay instead? If okay, then occurrence. Wait, so are we supposed to... Oh, these are valid users? Oh, no, okay. Then, is that good? Okay. Okay, what does it say? Read the following paraphrase section from Effective Go regarding maps. Maps are a convenient and powerful built-in data structure that associate values of one type. Alright, convenient and powerful built-in data structure that associates value of one type. Yeah. Okay. What do they want me to read? Effective Go regarding maps. Pretty sure we went over this, yeah. Like slices, maps hold references to an underlying data structure. If you pass a map to a function, contents of the map, the changes will be visible in the color. Maps can be constructed using the usual composite little syntax with colon separated keys. Key value pairs, so it's easy to build them during initialization. Missing keys. An attempt to fetch a map with the key that's not present in the map will return the 0 value for the type of the entries in the map. For instance, if the map contains integers, looking up a non-existent key will return 0. There's a map with the value type bool, so the map entry to true to put the value in the set and then test it by simple indexing. You need to distinguish a missing entry from a 0 value. If there is an entry UTC or is an entry for the UTC or is that 0, because sometimes you need to distinguish a missing entry from a 0 value. Is there an entry for UTC or is that 0 because it's not in the map at all? You can discriminate with a form of a multiple assignment. And this is present. Seconds will be set appropriately and OK will be true. If not, seconds will be 0 and OK will be false. Here is a function that puts it together with a nice error report. So if true, then return the seconds, otherwise to delete a map entry, use the built-in function whose arguments are the map and the key to be deleted. What I noticed with Go's maps is that there's not much you can mess up with maps. There's a lot of like safety guardrails that they placed in. Like in Python, there would be like a value error, key error, and stuff like that, like key error stuff. So that's interesting to see. Maps can have at most blank values associated with the same key. Many values, right? You can have could you have a list as well, right? Oh, wait, okay. If this is 1 to 1, then no, it's 1. A value where the key doesn't indicate returns a 0 value. A function who can mutate the value stored in the map and those changes original values. Mutate the value stored in a map and those changes blank the original values. A function can mutate the values stored in a map and those changes. Yeah, fact. I think they do. What does the second return value from a retrieve operation in a map indicate? A boolean that indicates whether the value at the key is a 0 value. Whether the value. Yeah. Last one. Let's do this. I have a lot of internal logic for sorting and dealing with customers. Complete the get name counts function. It takes a slice of strings and returns a nested map. Complete the get name counts function. It takes a slice of strings names and returns a nested map. The parent maps are. It takes a slice of strings names and returns a nested map. The parent's map keys are all the unique first characters. See runes. I gotta read. What are runes again? It takes a string of names and returns a nested map. The parent's map keys are all unique first characters of the names. The nested map keys are all the names themselves, and the value is the count of each name. Convert a string into a slice of runes as follows. Okay, so I can just copy this fab here, right? So we're taking a single character, a string that always is mapped to an integer. All right, return name counts. Oh, I see. I see what he's saying. Oh, okay. So we should do that. So I do this. Equals. So we made the thing. Then I need to make oh my god, bro, this is really annoying. This then is the whole name hold on. The name right, that makes sense, right? I get the name and I'm gonna increment. If it's not okay, then assignment to an entry in nil map. Oh, if it's not okay, then can I not add this? Oh my god, I have to check if this even exists first. God damn. Let me check if this first exists. Well, let's do this whole process. Hold on. If that doesn't exist, then do I do this? Nice. Oops. Take a slice of strings and return the total count of distinct words. Split split a string by space, go. Okay, strings.fields. Okay, so for every message in range messages, wait, what do I return? A distinct count. Result map a string to int. I should import the string. Import strings. Words message dot strings dot fields cnt word range words cnt so if wait, hold on, let me just do this. If word no, we get okay equals in cnt. Oh my god. If not okay, return, not return, we should cnt word equals 0. Else, I mean, not really an else, just a case here. Hold on, I need to strings to lower And then we can return I guess iterate key val of t I don't know if this right. Okay, never mind. I guess I'm getting way too many. I'm curious on what this will do. Okay. Val. Where's my... Oh. I guess I'm getting way too many. Oh, are you saying one discount distinct word? I'm counting all the words. Wait, hold on. I have an idea. Okay, I have an idea. I think this is okay. So, if not okay, make a new one, and this is a sign for uniqueness, and increment that. That should work, I think. Okay. There you go. Distinct words. 2 more to go. Social networking features to help users identify their mutual friends. Complete find suggested friends. It takes a username string, and a map and a map, or it's a map with an array of and a friendships map as inputs. The map keys are usernames, and the value of are slices of strings representing the direct friends of that user. Okay. The function should return a slice of strings containing the user's suggested friends. A suggested friend is someone who is not a direct friend of the user, but is a direct friend of one or more of the user's direct friends. Is a direct friend of one or more of the user's direct friends. Each suggested friend should appear only once in the slice, even if they're found in multiple direct friends. If there are no suggested friends, return a nil slice. For example, this is a whole LeetCode problem. Damn. So Alice is here. So we say this because Bob is friends with Charlie and David. And then wait, so Bob is friends with Charlie and David. Why do we say David? Is it because David is a friend of Alice? No. Wait, why not Charlie? Very difficult. Why is that? I don't know. I don't understand the output here. The output sounds really weird. Click for more info. The function returns a slice of strings containing the user's suggested friends. A suggested friend is someone who is not a direct friend of the user. Oh, so we didn't pick Charlie because it was a direct friend of Alice. We picked David because it's not in that list. Okay. And then we can't choose Alice. We're not going to choose Bob because it's in his direct list. We're going to choose David, but we already added David, so we skip that. So we choose Eve, as it's not in that list right there. Okay. Damn, this one is tricky. Do I gotta do some BFS here? Like, if I do a BFS traversal here, right? Right, if I do a BFS traversal, right? I start with the starting person, and then I just go, add all its friends, and then like a simplified BFS. So do I only add of the direct friends? So I only look at Bob and Charlie? a suggested friend who is not direct friend of the user, but is a direct friend of one or more of the user's direct friends. Okay. So I'm gonna assume that you only need to look for Bob and Charlie. So if I do Bob and Charlie, I need to do what if I make this a map? Okay, so I go to Alice. This is the people I need to look for and find their friends. So let's find their friends. So Bob, give me your friend. So for every friend in Alice's, check in the list, map. Check in the map. Okay, who are you friends with? Are you get your friends, loop through their friends. Loop through their friends. Can I add Alice? No, because it equals to the username. Can I add Charlie? No, because it's already in Alice's list. So I should make an Alice list. No. Can I add David? Yeah, you can, because it's not in Alice's list. So what's check if a value exists in a slice. Go. I'm gonna import slices. Hopefully it works. So let's do it. For every friend in range of friendships, for every friend in range of friendship, right? Wait, we're not, okay. In friend in the username. Right? Suggested friends. String. Okay, so we have a friend, which is so we look through Bob. So now with Bob, what do we do? Bob's friends. Friends. Friend 2. Potential suggestions is this right here. Potential suggestions is the friend. In the friendship. Potential friends. If for every potential pot, let's call it pot friends. Way too long to pot friend. Pot friends. Friend. Pot friend. If pot friend does not equal does not equal username and pot friend is not in slices dot contains friendship's username, then suggested friends equal append suggested friends to the pot friend. Return the suggested friends and everyone is happy. Oh, I failed. Oh, I think it's because I duplicated it. We could do instead of this one, we do the suggested friends. I failed all of them. Oh, I have to say not. Right? Because I don't want them in this list. That's the only, if they're not in any of these lists, then don't add then add them. And it should not equal the thing. Fail 2. Alright. Oh. Why? Oh, should I return nil if there are no suggested friends? Okay. If suggested, it's not suggested friends, return nil. I guess I can do. Oops. Should pass all of them. All right, good. Kind of brute forcey, but I can't think of an algorithm. So last one here. Let's go. Let's go. Keep going. Keep going. Take all of this here. So I guess there's a bug or something. There's a bug in log and delete and fix it. The function always delete the user from the user's map, which is a map that stores the username as keys. It returns a log string that indicates some color like this in the tree. Instead of using the delete function before each return, just defer the delete once at the beginning of the function. Oh, okay. Defer. And can I have this here? Would this work? Alright. Done with maps. Doing pointers next time. Ooh,
It is super critical to understand how pointers work.
Oh,
If you don't, it will lead to slow code or even incorrect code that's really hard to...
We'll get there soon, buddies. But that's for tomorrow. Thanks for watching from day 20. I'll see you for day 21 tomorrow. I'll catch you guys later.